So this is the code that we saw for the unoptimized version of JustReturn. And I want to now make a claim that the stuff in blue is essentially the setup and teardown of the frame pointer usage by this particular code. And the stuff in green is basically stuff we already saw. Set the return value, return from function. So that's the basics of what we actually need here. And so I'm claiming the rest of this is extras added for frame pointer handling. But how can I prove it? Well, I could tell the compiler to not include frame pointers by using the -f omit frame pointer argument to compilation. If I do that, then I have -f omit frame pointer down here, and that yields the following code, which is exactly what I said. We've got the set return value and the return from function. Ta-da! But also keep in mind, this is still not actually the same as the optimized code. The optimized didn't have this dumb little monkey business of moving 65 to A5 and then A5 to A0. It just moved 65 to A0 because that's what optimized code does. So what's the ultimate point of frame pointers? Well, they are helping to organize the stack frames into a singly linked list. And it looks something like this. Something calls into main. The main is going to call foo is going to call bar, but something calls into main, and that causes main to allocate a stack frame for itself. Subsequently, the frame pointer is saved by main, and the frame pointer is currently pointing somewhere up above main, and it will be moved down. And we'll see in RISC-V that it actually looks like it's moved down to pointing just below the frame for main itself. So you save it, you move down the frame pointer. Then main calls foo allocates a stack frame for itself. The existing frame pointer value is stored, so that is pointing where the current frame pointer points, and then the frame pointer is moved down again, pointing just outside or just to a higher address or just below from a stack bottom, stack top perspective, just below the foo frame. And again, foo calls to bar saves off a copy of the saved frame pointer. Saved frame pointer goes down. Now you'll see that it looks like the saved frame pointer gets stored at a slightly different location for this last function that's called. That's just going to be a little bit of foreshadowing for later on. But anyways, once bar is done, then it deallocates its stack frame by setting the frame pointer, the register, the S0 or the frame pointer register, to point at the same location that the saved one is saying to point to, and then it deallocates its stack frame. Then foo returns back to main, moves the frame pointer before it exits, and deallocates its stack frame. Main returns back to whoever called it, moves the frame pointer register back to whatever the saved copy is, and deallocates its own frame pointer. So obviously this is going to matter and make more sense once we get to functions calling functions, but that'll be later on in the class.